Hi, welcome to projectbuzzer.com. Now let me discuss about the title of the project. Our project title is Computing Spatial Distance Histograms for Large Scientific Datasets on the Fly. The main objective of this paper is our main goal with this work is to perform the SDH computation, that means spatial distance histogram computation on a high level of efficiency and accuracy. Specifically, our approach fundamentally improves our existing scenarios. This is overcome via a number of techniques that take advantage of spatio-temporal locality within the data and multi-core parallel processing architecture of modern GPU. Now let me discuss about the abstract of our process. This paper presents a highly efficient and practical algorithm for processing SDH of large-scale MS data with improved efficiency and accuracy over existing solutions. To achieve this, the algorithm takes advantage of two types of uniformity widely present in MS data. To further improve the running time of the algorithm, we utilize the GPUs. In this paper, we focus on an important query in scientific simulation data analysis, the spatial distance histogram. The computation time of SDH query using brute force method is quadratic. Often, such queries are executed continuously over certain time periods, increasing the computation time. The key idea of our algorithm is to derive statistical distribution of distances from the spatial and temporal characteristics of particles. Upon organizing the data into a quadtree-based structure, the spatio-temporal characteristics of particles in each node of the tree are applied to determine the particles' spatial distribution as well as their temporal locality in consecutive time periods. We propose highly efficient approximate algorithm to compute SDH over consecutive time periods with provable error bounds. We report our efforts in implementing and optimizing the above algorithm in graphical processing units as GPUs as means to further improve the efficiency. The accuracy and efficiency of the proposed algorithm is backed by mathematical analysis and results of extensive experiments using the data generated from real simulation studies. Now let me discuss about the demo of our process. First, our process starts itself from home.java. Just right-click and click a run file. Our project title is Computing Spatial Distance Histograms for Large Scientific Datasets on the Fly. Then just click on that frame. How to choose your dataset. That means spatio-temporal dataset. Then load dataset. This is our dataset. In that we have a time and date, latitude, longitude, and then region names are here. Then we are going to extract the attributes. Here itself data set has been shown here. Then these data set has been loaded into a database. Items are loaded into a database. Then view the data set. This is a S number, serial number. This is a ID. Then date, time, latitude, longitude, and regions will be available here. Then click next. Extract regions. These are the regions. Then extract latitude and then longitude, and then we are going to update the positions. Region positions are updated. Then distance has been calculated based upon this formula, distance formula. Then we are going to extract the uniform regions. These are the all regions displayed from latitude and longitude. Here we are going to clustering the regions into uniform and non-uniform regions. Here we are identifying uniform regions. Here we are identifying non-uniform regions. In that we are classifying uniform regions based on latitude and latitude. In that also here we are calculating non-uniform regions based on longitude and latitudes. Then we are going to extract the regions which is based on the probability calculations. In that PDF formula has been calculated. Here formula is displayed for probability density function. Then here we are extracting the regions. Then here we are predicting the region PDF, and then calculating the PDF for x and y coordinates PDF values. Then here next process going to estimate the distance. In the spatial distance calculation among region pairs based on the STH. Here we are extracting the regional pairs, and here we are estimating a SDH, that means spatial distance histogram. It takes some too much of time for because it is estimating for large data set. After estimating the SDH, spatial distance histogram, we are update that information into a database. SDH is nothing but a spatial distance histogram. The processing of spatial distance histogram of large data, MS data, with improved efficiency and accuracies. Spatial distance has been calculated and update in a database. These are the regions, neighboring regions, and spatial distance has been calculated. Then we are going to calculate the temporal calculations. In that we are estimating the temporal regions. Temporal regions means we are calculating a consecutive time taken for processing the STH. Here we are improving the runtime of the algorithm based upon the STH. In there we are also calculating the GPU, that means graphical processing units. And temporal calculations is calculated based on the distance estimated. Consecutive time has taken calculated. Then click the time taken button. Then here we are having a regions, neighboring regions, spatial distance, and consecutive timings. And then click search option. Then we are going to search about the source region and then destination region. Here we are going to fetch the paths. Then click the accuracy. Here we are displaying accuracy based on the spatial distance, then average temporal time. Then here we are displaying efficiency based on the efficient ratio predictions based on the accurate distance and traffic density by using STH algorithm. So this is the complete flow of our process. Thank you for watching.